Today, me and Akbaram will co-presenting at this InfosysCon 2025 to talk about how to secure your Kubernetes clusters using Kyverno. So a little bit about the agenda of today. We're going to start with the problem statement, and we'll dive into how Kyverno works and the overall architectures of Kyverno, and then we'll dive into the new policy types that we're adding to Kyverno release, starting from 1.14 release. And then we'll hand off to Akbaram to do the demo and showcase of the new policy types in action via the Kyverno Playground. And he also talked about his contribution experience at Infosys. And then we're going to talk about how you guys could start contributing to open source project like Kyverno. We'll save the last 10 minutes for the Q&A session. Okay, so, right, I hope I'm not losing the connection. So let's start with the problem statement. So you would wonder why, people would need a policy engine like Kyverno for your Kubernetes cluster. So imagine as a platform engineer, you would want to ensure the best practices of your pods and workloads to, for example, not run as a root user, or you just basically want to restrict all the incoming workloads to not be created in the default namespace or any of the system namespaces. And you want to validate all the images are coming from the trusted images. You don't want to expose any supply chain security issues from your cluster. Additionally, as a platform engineer, sometimes you may want to automate the creation of the network policies for your incoming namespaces. You want to replicate all the image post secrets to inject as default into your incoming workloads, or just simple as removing all the bare pods running in your cluster, right? So problem like that, you definitely don't want to solve manually. Here comes the policy engine available for your Kubernetes, right? You want to automate everything as many as possible so that you can offload some work with managing your clusters for the company. So how Kyverno works, right? We have Kyverno deployments by default. Creates 4 different controllers. It can run as the default dynamic emission controller, which receive the emission request via either the validating or mutating emission webhook, or you have the policy report controller running periodically in the background to scan the existing resources to report all the policy reporting violations or the policy evaluation results. You have the background controller, which generates the default resources or mutate the existing resources like patching labels to your deployment. You have the cleanup controller, which schedules the removal of stale resources like mentioned earlier. You want to clean up all the bare pods running in your cluster. Or you have another option to run Kyverno as a standalone CLI to have the early access of the policy evaluation results before scheduling all of your resources into the Kubernetes cluster. This can be automated or integrated in your CI/CD pipeline so that you don't, need to get the runtime error until you actually schedule something in your cluster. So let's look at the Kyverno architecture, right? So on the top, it's the standard emission flow of how an emission controller works in Kubernetes cluster. And underneath that, you have this little black box containing all the blue small boxes. Those are all the Kyverno components, right? As you can see, we have the emission controller, we have the cleanup controller, report controller, and background controller. Those 4 controllers made of the Kyverno deployment. And in the small yellow boxes, there are all managed resources by Kyverno, right? As you can see here, we have the cleanup policies, we have different types of the policies, we have the policy report for the violations here, historical data records of the policy evaluation results, and you also have the policy exception, which you can do the exception across all the policies globally, right? So I'm excited to introduce the new 5 policy types that are available in starting from Kyverno release 1.14. So you may wonder why 5 new policy type, right? Let's start with the result. The result is that we are introducing 5 different new policy types based on CEL expressions as the policy pattern to achieve all the use cases listed on the right-hand side, including the validation, mutation, generation, cleanup of resources, as well as verifying image signatures, as well as payloads. And now you may wonder, why do we move to different 5 new policy types, which are all based on CEL? Here, I'll tell you why. So if you look at the screenshots, I'm doing a kubectl explain to inspect the cluster policy, CPOL as cluster policy, the validate subgroup, right? I'm inspecting cpol.spec.rules.validate. And now you can see that those are all available patterns under the cluster policy validate subgroup to achieve one single use case. Imagine you're defining the pod security standards, like preventing pod from running as root user. You can achieve it via any pattern, via CEL expression, via denying root, or even via the pattern, the pod security, which integrates the Kubernetes pod security emission component, right? So there are a lot of different options when it comes to a single use case when you want to write a validate subgroup via the type of cluster policy. And we got this question quite often, right? Which subgroup type should I choose, and why would I choose that, right? But now with the unified policy pattern, which is based on CEL expression, which is common expression language, you are able to write CEL expression across all different types in the unified format. So you don't need to bother choosing different patterns in between. Now all policy patterns come with CEL. And why CEL? Because as you know, Kubernetes validating emission policy uses CEL, mutating emission policy uses CEL as well. And there's other CNCF projects like SDU project, Gateway API server also uses CEL. So you can see there's a trend in the CNCF landscape, including, Kubernetes are adopting CEL. So CEL here in Kyverno not comes as the alternative pattern in Kyverno. It'll become the fundamental pattern of the Kyverno policy types. But in the meanwhile, you don't need to worry if you're already a Kyverno user. We're gonna support the existing cluster policy type, and also adding the support for the CEL-based policy types as well. And we will provide the migration path for you to move all of your cluster policies to new policy types using CEL. So we have the backward compatibility guaranteed. We have the support for both YAML-based policy patterns and CEL-based policy patterns. So you don't need to worry there will be a breaking change in Kyverno, but we're embracing the CEL change in the CNCF landscape. Okay, with that, you may wonder, what does a CEL policy looks like, right? So we'll go through all the 5 new policy types in action later by Kyverno. But now let's understand how the policies are made of, how you can construct a new policy type using CEL expression, right? So as you can see on the top, we have the API version available in this new group, policies.kyverno.io, in the V1 Alpha 1 version, and with the client validating policy. with the metadata that you all are familiar with, all the Kubernetes resources. And here it comes with the spec, which has the match constraints. Basically, the match constraints selects all the matching resources you want this policy to be applied to. Here, I'm defining the resource as pods with the create and update operations, which means I want to apply this validation check to all the incoming pods with either the create or update events. And now let's look at the validation pattern, right? I have two expressions here. The first, I'm referencing the containers, all the images inside the container, and making sure your image comes with a tag. So a tag is required in this case. And the second expression, I'm also referencing all the images in the container again, but here I'm parsing the image tag and say that it cannot end with latest tag. I have the negative operator here checking, okay, your image tag cannot be ended with the latest tag. So here it's a validating policy. It's a simple example to say that I do not allow any pods running with either latest tag or without any tag. So you must use a version tag or a hash tag for your incoming pods. That's straightforward, right? And now let's switch to the image validating policy here again. Are we getting a question?
We can take the questions at the end.
Okay. I just heard some noise. I thought it was a question. But let's continue on the image validating policy. So now in the same API version group, you have another kind as image validating policy. Same here with the metadata. You define a name for your image validating policy. And in addition to match constraints that we just looked at earlier, you also have match conditions, which allows you to define different conditions to select based on either the namespace, the selector, or any attributes that are available from your incoming objects. And here, most importantly, I'm matching all the image references that's coming from a certain glob. Here I'm selecting all the images coming from the GitHub container registry, right? That's from ghcr.io. So basically, I'm trying to apply this policy to all the container images coming from the GitHub registry. And I'm defining a attester here, right? So we have two different options as the attester. You can either sign your image using Notary Project, or you can sign your image using cosign. So those are two different solutions that we support for the attesters type. And basically under the notary attribute, I'm attaching the cert that I used when I signed the image. So this cert will be used when verifying the image signature because, you give the cert when signing the image. You also want to use the same cert to verify that the signature is signed by this specific certificate. And under the attestation attribute, I'm defining a SBOM with a specific referral type, SBOM, SecLongDX, that'll be used later in the policy pattern, validation pattern. Right, similarly, in the image validating policy, I'm having 3 different expressions, which means I'm checking 3 different conditions, right? So let's look at them one by one. The first expression, I'm iterating through all the images extracted from your incoming deployment to verify the image has the signature, which is signed by this attester notary, as I specified earlier in the policy. Remember, I have the attester notary specified here attached with certificate when I used to sign the image. So that means your incoming image must be signed with this notary cert. And the second condition is the expression I'm checking. All the container images must have a signature attached for your attestation with the type SBOM. right? Remember, we have the attestation SBOM defined with a specific referral type, SBOM cyclone DX. So here I'm checking that all of your container image has the attestation signature as well. If your image doesn't have the attestation signature, then I'm gonna fail your resource creation or update. And the last condition is that I'm iterating all the container images, extracting all the payloads. So I'm pulling all the image payload from remote registry and trying to make sure you have the SBOM of type format cyclone DX, right? Those are the custom data that you will attach to your image when you're building and signing your image. It can be the security vulnerability reports attached to your image, and you're going to check whether there's a critical or high severity security issues, or you can check any other type of SBOM payloads that are attached to your image while building and generating the image, container image. Again, this is an example of notary signing. You can also do the cosign signing. We have the documentation available on Kyverno.io. So if you're having a different use case, feel free to check the examples on our website. So moving on to the next policy type, we have mutating policy. And again, here comes with another kind, mutating policy. It has all the same match constraints, all the same metadata. But here I'm just matching a deployment creation event. I'm saying that for all of your incoming new deployments, I'm trying to do a JSON patch to mutate a label with key managed and set the value to true, right? So which means for all the incoming deployments, I'm patching a label to say those are managed deployments. So this mutation can be automatically patched by Kyverno mutating policy. And here again, you may notice that we have the patch type JSON patch. You can also do a different patch type, which is apply configuration type of patch, which is similar to strategic merge patch that is available in cluster policy type. So it's kind of an overlay patch type. If you have used customize, you must be familiar with that. So you don't need to define the JSON patch with the operation patch and value. Just do the overlay style, and then it'll patch any mutations to your incoming resource. And by the way, it's worth mentioning that for all the mutating policy and validating policy, Kyverno can automatically convert them to Kubernetes built-in validating emission policy and mutating emission policy. So what does that mean, right? So as you know, those validating emission policies and mutating emission policies are built-in policies available in Kubernetes. Those are all executed at the API server side. So with this, you don't need to worry about adding extra latency while executing the emission webhook. Everything will be executed at the API server side. So you are able to get the emission response, or you are able to create the resource without adding any extra delay for either the mutation or validation. So those are all achievable via this auto conversion of mutating policy and validating policy. And now here comes the generating policy, right? Again, another type generating policy comes with metadata and match constraints. Basically, this policy says for all the incoming namespaces, I'm going to create some default resource in that namespace, right? Imagine you are a namespace owner. You want to provision a namespace with some default resources like network policy, the config map, the default secrets, or the roles or role bindings to help you provision the RBAC permissions for the namespace owner. Those can be done via the generating policy. And here, as you can see, I'm having a different pattern here called variables. I'm defining the entire config map data as a variable in this generating policy. As you can see with the kind config map, I'm giving it a name. and all the customized data. Here it contains the addresses for Kafka service and Zookeeper service. And under the generate expression, I'm accepting the generator.apply filter. The first variable here accepts the namespace of the config map and then comes with the actual data of the config map itself. So with this generating policy, whenever you have a new namespace coming in, I'm going to create or provision a new config map containing the default Kafka and Zookeeper addresses for your incoming namespace. Last but not least, we have the deleting policy available. Here with the kind deleting policy, I'm having another custom conditions attribute. Here you can select based on the resource namespace, name, selector, annotation, or any of the fields that are available for your matching resource. Here you can see the matching resources pod itself. And under the schedule attribute, I'm defining the cron formats. So this policy, which means it does the check every minute to check if there's any pod that is available in the default namespace, come with the name example. So every minute, Kyverno will execute this deleting policy and try to clean up all the stale pods with the matching conditions. All right, so with that, let me hand off to Akbaram for the demo. So we'll showcase all the examples that we just looked at via the Kyverno Playground, and we'll talk about the contributions and the questions later. So with that, let me stop sharing and feel free to take it away, Akbaram.
Thanks, Shooting. Yeah, let's move on to the demo. Let me try to share my screen. Can someone confirm if you can see my screen?
It is visible.
Okay, thank you. Okay, so we talked about security best practices that we implement in Kubernetes cluster. We talked about running pods with non-root user. We talked about blocking pods if they are using image with the latest tag. So different type of use cases we discussed. So let's see how Kyverno can be used to enforce those security best practices in the Kubernetes cluster. So for different types, we need to deploy Kyverno. The best way to deploy Kyverno is using a Helm chart. So different type. Before deploying, we need to understand what version of Kyverno in a Kubernetes cluster. So I'm using Kubernetes 133. So there is a compatibility matrix that we need to refer to different type, identify the Kyverno version that works with Kubernetes 1.33. So as per the documentation, so I think the latest the Kyverno version that is tested is on Kubernetes 1.32. So we can consider 1.14.x. So let's look at the latest version and we deploy this. So we need to add the Helm repository. Then we can look at the Kyverno versions available in the repository. So we need 1.14.x. So this is a app that works with Kubernetes 1.32 and higher. Let's use this version and deploy it.
Is it possible for you to set history and share all these commands in a notepad?
Yeah, sure, I'll do that.
Yeah, thanks.
So the Kyverno is deployed. Let's see what resources are running. So if you recall the architecture diagram, we have seen different controllers, right? So Kyverno deploys admission controller, background controller, cleanup controller, and reports controller. So these are the 4 controllers you get when you deploy Kyverno. Give it a minute, so it will be started. And we also discussed that Kyverno is an dynamic admission controller, which means that the Kyverno implementation is done outside your Kubernetes code. Kubernetes also has some inbuilt admission controllers, but Kyverno is also a controller, but it runs outside the Kubernetes. So when you deploy Kyverno, basically it registers 2 webhooks: validation webhook configuration and mutation webhook configuration. See, these are the validation webhook configuration that gets registered when you deploy Kyverno. See, what this does is, whenever you deploy a resource to a Kubernetes cluster, first it goes to API server. Then API server looks at the request, validates it. Then it will send an admission review request to the Kyverno. So Kyverno would intercept that request and it will try to match all the mutation policies, and it will execute those one by one in a sequence. Then if there are any validation policies matching the resource, so Kyverno also executes all those validation policies. The difference is that mutation policies are executed in a sequence, whereas validation policies are executed in parallel. And if there is any violation from any of the validation policy, the resource gets blocked. So Kyverno would send a violation flag to the API server, and API server would block the request and it will send a warning message. If there are no violations, it will be deployed. Let's look at one of the validation policy that we have seen, and we'll try to deploy a resource and verify whether the policy works fine or not. So all the controllers are running. Let's pick one of the validation policy. So there are multiple ways you can test a policy. So there is a Kyverno playground that we can use to test the policy against the resources. So anyone can access this URL and you can write your policy and you can test any policy that you want to deploy. Okay. So I'm going to deploy this policy in the cluster. Okay, I have deployed the policy. Let's verify. So what this does is, if you try to deploy any pod with the latest tag, or if you are trying to deploy a pod image without any tag, so it should be blocked. So that is what this policy does. Let's try to create a pod without any tag. See, the admission controller is blocking this deployment. Says the request is denied because the image with the latest tag or without tag is not allowed. Let's try to deploy with the latest tag. So again, with the latest tag, this resource is blocked. Now, if you deploy a proper tag, it should be allowed. Let's look at what is there. 14.4. See, the pod is deployed. So this is how Kyverno enforces best practices in the cluster. And you can also validate the policies against resources that you want to deploy in the cluster using this playground. So you have a policy on the left side, right side you have different type of resources, one with a proper tag, one without a tag, then another resource with the latest tag. You can just hit start button, and this will show that pod with the tag is allowed and others are failed. So this is how we can test. Let's look at another policy, that is image validation. See, one of the use case where we need to validate the image is that you need to make sure that the image that you build should be deployed in the cluster. So how do you do that? Because see, you have a team, multiple people build the image and they push to the registry. It's possible that you build an image with a version tag as a v1 and you push it to the registry. Some other person also builds the image with version 1 tag. Then what happens? The existing image will be overwritten, right? So how do you ensure that the image that you build should be deployed? So what you should do is, you after the image is built, you attach a signature to the image. Then when you deploy it, verify that the signature that is used to sign the image matches on the image when it is being deployed. So in such scenarios, you can use image validation policy. So there are two types of tools. Popular open source tools like Notary, CoSign are used to sign the images, and these tools are supported in Kyverno. So in the use case that we are looking at, actually this image is signed with the Notary. So Notary provides a notation, a CLI, which you can install and use to sign the image. After it is built, you sign the image, and you can push it to the registry. You can use self-signed, or if it is a production, your organization will have a certified authority. You can use that to sign the image, and you attach the certificate in the policy, and then deploy this policy. Then Kyverno, when you deploy the resource, Kyverno would download the image, and it will try to match the certificate from the policy with the certificate signed on the image. If there is a match, then only it will be deployed. And also, you also generate the software bill of materials after the image is built. Basically, the SBOM is nothing but the different dependencies, libraries, components that are used to build your application, build your image bundle. So those are generated using open source tools like Trivi and Snike. So both Notary and this CoSign supports those SBOMs using those tools. And basically, you can generate those SBOMs in Cyclone DX or SBD DX, but Cyclone DX is the most popular format. And so you can also validate the format of those SBOM files using Kyverno policy. So basically, in this policy, so you are verifying whether the image has a signature or not. Then, and you are also validating that signature on the image is matching with the certificate that is defined in the policy. And third, you're also validating the format of the SBOM file, that it is matching with Cyclone DX. So these are the different type of validations you can perform on the image before you want to deploy that in the cluster. So I have given one signed image and one unsigned image, and let's test this policy. You should see that one resource should be passed and other should be failed. See? So this is a bad pod. Bad pod, you see it is failed, and there is a good pod, so it is passed because the signature is matching with the certificate. Let's look at one more example. We will look at generating policy. So some of the policies like mutating, generating, these are newly added in Kyverno. You don't find them in the, they are not released to the public. So they are available in 1.15 dev version. I think maybe in the next release they'll be made available to the public. You'll have some use cases wherein you want to automatically create some resources based on some action. Let's say you are creating some namespace. Whenever a new namespace is created, you might want to create a network policy. You might want to create a resource quota for that namespace. As we have seen in the slide, you might want to create a config map. So in those cases, you can look at generating policies. So this policy is used to generate some resource automatically whenever some resource is created or updated. So depending on these operations you want to create. So in those cases, you can look at generating policies. And if you want to run this Kyverno in a highly available environment, so this is how you do it. So you should run these controllers with more than one replica. So that way you will not have any single point of failure. So this is a recommended configuration for a production environment. And coming to the Infosys contribution, so we are in the top 10 contributors to Kyverno projects. So there are mainly 3 main projects where we do contribution, like a Kyverno website, then Kyverno policy engine, there is a Kyverno policies. So what we do is, so we pick up these repos, we look at those issues, and there are different categories you have. So there are good first issues, which are simpler issues. You can just look at those and understand what the issue is and see if you can solve it. And if you need any clarification, so we reach out to the Kyverno technical team. So there is a Slack channel through which we communicate with them, and we get clarification, and we work on that and we'll fix it. And once it is done, we'll reach out to them and say that, okay, so this is a issue we picked up and we solved it, and we ask them to review, and so post review, so they will merge the issue, the resolution with the repo. There are some test happens, and post that it will be merged. And there are bugs also we can look at. So yeah, then there are people who have contributed to documentation also. So these are the 3 areas where we have done contribution. And if you have done more than 5 contributions, you will be awarded Kyverno contributor award from the Nirmata. So you'll also get a Kyverno logo, which you can add it to your signature. So that's a good thing you get with your contributions. So if you want to contribute, so what we need to do? So you need to understand what this Kyverno. So we have given some overview, but if you want to get some deeper understanding, so we suggest you go through this admission controller overview, how admission controller works in Kubernetes. Then there is a quick start. So this will give you some instructions on how to install, how to use Kyverno. And if you want to play with different type of policies, you can access this Kyverno policies website. So if you compare with any other policy engines, Kyverno has advantage because
Kyverno has 300 plus policies in their library. So most of your 90 to 95% of compliance rules, security best practices already covered in those sample policies. So depending on your requirement, depending on the rules that you want to implement, you can just refer those sample policies, and you can adopt whatever needed in your environment, and you can just play in the, you can use the Kubernetes playground and test it. Then you can implement in your cluster. And if you see that, okay, you have some requirements, but you are not able to find those the policies for those, you can always reach out to us, or you can raise a PR in the Kyverno policies depot. So we will look at that and we will try to create those custom policies. Okay. And yeah, coming to the contribution. So these are the three main repos under Kyverno organization: the policy engine, the policies website, where we do most of our contributions.